In this video, you are going to find out about the properties of a unique quadrilateral. It's called a trapezoid. It has a very particular property to it. So let's review what we already know. The conditions, what conditions does a figure have to meet in order to be a polygon? It's formed by the three or more segments called sides, and the two sides are not collinear. Each side intersects exactly two sides, one at each endpoint. What condition does a polygon have to meet in order to be a quadrilateral? It has four sides. We remember that quad is the prefix for four. What condition does a quadrilateral have to meet in order to be a trapezoid? Exactly one pair of opposite sides are parallel. We use the word exactly so that we know that it's no more than one pair of opposite sides. A trapezoid is a quadrilateral with exactly one pair of parallel sides, and the parallel sides are marked with matching arrows. So segment AB or side AB is parallel to side DC. What do we call the parallel sides of a trapezoid? Bases. The bases in this trapezoid are AB and DC. How many pairs of base angles does a trapezoid have? Why would this make sense? There are two pairs consisting of two sides. So one pair would be AB and the other DC. Now, what do we call the non-parallel sides of a trapezoid? Legs. Makes sense there. Now, the legs aren't always facing the way they are in this picture. You might say that the legs make sense this way. They're just whatever are the non-parallel sides of the trapezoid. There's a special kind of trapezoid called isosceles trapezoid, where the legs are actually congruent. So in this picture we can see that the sides that are parallel are not congruent, but the legs of the bases, between the bases, are congruent. If a trapezoid is isosceles, then each pair of base angles is congruent, and the converse of that is that if a trapezoid has a pair of congruent angles, then it is called an isosceles trapezoid. Find the missing angle measurements based on what we know. Now, the trapezoid is not a parallelogram, so we can't use all of the properties that we've learned before. But what did you learn earlier this year about the relationship of angles that are between parallel lines? First of all, because the first example is an isosceles trapezoid, the base angles will be the same, so x will be 110. And what will z and y be? They will be congruent, and they will actually be supplementary to the 110, which means that z and y will be 70 degrees. And 110 and 110 is 220. 70 plus 70 is 140, added to the 220, and you get 360, which is what we expect for all quadrilaterals. Okay, the next example is another isosceles trapezoid. Angle B, 53 degrees. The sides are congruent. The bases are parallel. D and C will be supplementary to the 53 degrees, and that leaves us with 127 degrees. Now this next one is tricky. You see that 3 out of the 4 angles measurements have been given. You can't ignore the information given, so you have to add those 3 measurements: 132, 91, and 90. I'm going to give you time to get that set up. Add them, and I'm sure that you got 313, which you subtract from the 360, and you get a final angle measurement of 47 for angle C. Now on this last example, it's back to an isosceles trapezoid. B is going to be 108. C and D is the difference between 180 and 108. Let you do your math. 180 minus 108, you should have gotten 72 degrees. Clear that up. Okay, we have some more examples. Find the missing angle measurements. What do you know? How can you proceed? Look for the parallel marks to make sure that this is a trapezoid. Notice that the opposite angles are not congruent, and they're not supposed to be congruent. What else do you think that you can presume? If angle C is 90 degrees and consecutive angles are expected to be supplementary, in this case, they're corresponding angles between parallel lines, and we learned that that does mean that they have to be supplementary, so D is 90 degrees. When we do the other calculations, the only thing that's left is that angle X will be 118 degrees. The next one, where we have 2 angles given. One is 132 degrees, the other is 90 degrees. Again, we have parallel lines, corresponding angles. A and D will be the same. Because D is 90, A is 90. We do our math. 180 plus 132. The only thing that's left is 48 degrees. You could also do that if you subtracted 132 from 180. Our one on the bottom, both of these are isosceles trapezoids. So angles Base angles will be congruent. If C is 77, D is 77. And the difference between that and 180, if you wanted to go with consecutive angles, will be 103. Now I said consecutive angles. Could I have said corresponding angles? We're in the same place. For the next example, 112, match them up, 112, and the difference is 68. Complete the statement with always, sometimes, or never. A trapezoid is never a parallelogram. The bases of a trapezoid are always parallel. The base angles of an isosceles trapezoid are always congruent. Sometimes. Which do you think? They're sometimes congruent. It depends on the length of the legs, and the legs of the trapezoid are sometimes congruent. Moving on. The mid-segment theorem for trapezoids. Yep, there's a mid-segment. It is the segment that joins the midpoints of its legs. It is parallel to the bases. Its length is half the sum of the length of the bases. I'd like you to complete the rest of page 21 to find the length of the mid-segment for trapezoids, but we'll do the first one together. The bases are 7 and 13 units long. The sum, therefore, is 20. Half of the sum is 10, so the length of the mid-segment is 10. You've done a good job. Finish up the rest of page 21 and have a good day.